All right, so we're continuing our work in section 8.3, where we're going to look at example 4. So in example 4, we're going to practice again giving a formal proof that a series diverges. So far we've only used this divergence test to determine divergence. So let's go ahead and use that. And we can look then at these terms and wonder, do they go to 0? So in order to determine that, we first need to find the limit of the terms. So since the limit as n goes to infinity, and maybe I'll say that if we don't know the result, so we're told to show this limit this series diverges. If we don't know if it does or not, then using the divergence test is kind of a first check. So we might want, or what we will want to do, is use some scratch paper and compute that limit on our own first. 3e to the n plus n limit, n goes to infinity. Oh, we see that it's infinity over infinity, so we need to use L'Hopital's. So we're going to do some work, and we are going to find it's not 0. So once we do that scratch work on the side, then we are ready to start our formal proof. All right, so then that would look like, since the limit as n goes to infinity of e to the n plus 1 over 3 e to the n plus 1 is equal to, now notice, n goes to infinity, that numerator goes to infinity, denominator goes to infinity. So by L'Hopital's rule, that's equal to the limit as n goes to infinity of, so derivative of e to the n plus 1 is just e to the n. Derivative of 3 e to the n. Oh, and that was a plus n. So the derivative of 3 e to the n plus n is going to be 3 e to the n again, plus 1. Now we can determine again, oh, numerator goes to infinity, denominator goes to infinity. So what are we going to do? Well, we just need to use L'Hopital's rule again. But we see that it's getting better. Why is it getting better? Well, this extra term in the denominator is getting smaller. It will go away. And then our ENs will cancel. And so as we do more of these, you're going to see that there's some patterns like that that you can use that will start giving you insight about what the limits are going to be approaching. All right, so derivative of numerator is e to the n. Derivative of the denominator is now 3e to the n. So look what happens here, but these e to the n's cancel out. So this is equal to the limit as n goes to infinity of 1 over 3, which is 1 over 3, which is not 0. So since this limit is not 0, that means the series sum from e to the n plus 1 over 3 e to the n plus n, where n is going from 1 to infinity, diverges by the divergence test. And so we can check that we've included all of the correct elements here. So we are in fact writing it in complete sentence. We are using our notation correctly throughout. We are providing justification for each of our equalities or statements that we write, and including the theorems that we use. Awesome work.